EuroGO-SHIP Atlantos QC is an interactive open-source tool for performing first-level quality control on hydrographic cruise data. This interactive application supports EuroGO-SHIP goals by improving the first steps of quality control for hydrographic and biogeochemical data collected during research cruises. It helps make quality control steps more consistent by guiding users to find out flag outliers and check how accurate the measurements are. The tool includes simple plots that show how key parameters are related, making it easier to spot problems in the data. With a clear and easy-to-use interface, it helps users review the data and decide if it is reliable before sending it to shared databases. These are the technical requirements, which were the first considerations taken into account during the development of the application. Interactive and visual data support. The application includes ready-made, customizable plots that combine some parameters, making it easier to spot patterns or issues in the data. Works on any platform. It works on Windows, Macintosh, and Linux, so users can run the application no matter what system they use. It is built with open source. That means that we use open source tools and share the code in public repositories, so it's free to use, easy to contribute to, and not tied to any licenses. Clear and detailed reports, meaning that the application creates full reports of any change, readable by both people and machines, which helps with transparency and further data analysis. To meet the requirements of cross-platform compatibility, interactivity, visual data support, and openness, the application integrates open-source technologies. Python handles data processing, while Boki provides interactive visualizations through its two main components: the Boki server, which manages data updates and interactions on the backend, and Boki.js, the client-side library that renders plots in the browser. The application is packaged with Tron to run as a standalone desktop application on Windows, Macintosh, and Linux, embedding the Boki's interface without needing an external browser or server. All components are fully open source and publicly available. The application helps ensure internal consistency within each hydrographic dataset by assisting in identification of errors in the data. The units confirms that all measurements use the appropriate and consistent units. This means meters for depth, seconds for time, avoiding interpretation errors. The outliers highlights data points that deviate significantly from expected range or neighboring values using interactive visual tools, allowing users to review and flag anomalies. Formats assist in verifying that data entries follow a standardized format for timestamps, coordinates, and numerical precision, ensuring compatibility with other processing. Obvious errors facilitates the detection of clearly invalid values, such as negative depths or coordinates outside the expected area, so they can be corrected or removed. The application supports multiple data formats, including WHP exchange files with headers and units, standard CSV files, and a custom AQC format used exclusively by the tool. It also handles a spreadsheet. Excel and ODS files organize main data and metadata across separate tabs. WHP exchange files are CSV files that include metadata at the beginning of the file. This format is the actual de facto standard for reporting oceanographic data from cruise sections, used and recommended by EuroGO-SHIP and the Network's Data Center, the Cleaver and Carbon Hydrographic Data Office. We will use it to define the parameter names and quality flags in the application. These required parameters need to be present in exchange bottle files. They must have values present in the data lines as well. The application uses WHP exchange bottle names internally, but can translate common alternative names into their WHP equivalents to simplify usage. When exporting to WHP format, the correct standardized names are applied. The listed parameters are mapped during file loading into the program. These are the most common parameters used in the WHP exchange format. The flag standard values used in the application are a set of numeric quality flags defined by the World Ocean Circulation Experiment to classify the reliability and status of oceanographic data. Each flag indicates a specific data condition. When files are loaded into the application, some default parameters are automatically calculated if the necessary source fields are available. The first table lists the combined basic parameters. These use different source columns to extract their values, helping to unify column names so they can be used consistently across all formulas. If you want to see how each parameter is calculated, you can check its formula directly in the application. In general, if you already have the application installed, the main workflow will be: load a file, customize the application layout by adding or removing plots or tabs, check suspicious outliers. You can use other tabs or plots to see how the sample appears there. It's also possible to use the application tools and calculate parameters to help with this task. Once the changes are done, save or export the project and the report of actions if you need. There are two main ways for installing the software. Installers. Verified release for major operating systems are available on GitHub under the Releases section. Installing from official release offers two main advantages. Simple installation, because you just need to click on the installation file. Automatic updates, because the application checks for new releases and updates itself. And once installed, the application can be launched using the shortcuts created by the installer. Development. You can also install the application from source using the code on GitHub. The README file contains step-by-step instructions. This method is more complex as it requires having Python, Node.js and a package manager like Yarn or npm already installed. Installation process using installers. You can download the installer from the project's GitHub page under the release section. You will also find direct links in the README file. Once the file is downloaded, simply run the installer to complete the setup. Load a compatible file and configure the layout in the project settings. The first step is to open a data file. Supported formats like CSV and spreadsheets will be recognized automatically. If the files are processed successfully, the project settings form will appear. Otherwise, error messages will be displayed. The application then provides a predefined default layout on that form. Let's describe the elements that are shown in the project settings form. Project name. The file name that is being opening will be the project name by default. The tabs means that the application will generate tabs for the parameters it recognizes in the data file. Under each tab, predefined plots based on available data will be shown, allowing the user to add, modify, or delete them. When selecting a parameter, some will appear in green. These are automatically calculated by the application and were not originally present in the file, helping with quality control 1 and outlier detection. Calculated parameters also include those estimated by pre-trained neuronal networks. Once the user agrees with the settings, a Set and Plot button should be pressed. The application will then render the layout and present the main interface. You can also access the project settings after the file is loaded to modify the layout at any time. How to change the default application settings when loading a file? The default layout displayed in project settings can be customized by the user. This is done by opening and adjusting the application settings from the welcome screen. In this example, we are opening a file that contains a column named dummy external. If the column dummy external flag W doesn't already exist, the application will automatically generate it to flag the original column. This behavior is configurable in the application settings. Now I'm going to explain how to do it if you want this parameter to appear in the layout by default every time a file is opened. Open the application settings and navigate to the columns section. Here you can add new columns. We will use this to create the dummy external column, but within the application we will assign it to a different internal name, dummy external. This demonstrates how the application maps field names internally. You can also view other fields that are processed similarly. When defining a new column, several attributes can be configured. Name in application. This is the internal name shown within the application. Name in file, the name used when importing or exporting data. Data type is the expected type for the column values. And basic, if enabled, the column will be included if it encounters only not a number of values. This is useful if you expect to populate the column later. Required ensures the column is present in the file. The application will show an error if it is missing. Non-quality control prevents the application from auto-generating a flag column for this parameter. Precision is only applicable for float-type columns. This defines the number of decimals when exporting the file. Internally, the application preserves the original precision. Unit is an informational field that indicates the unit used by the column. Once the column is created, you can add a new tab to the layout that includes it. After saving the updated layout, any file containing this column with data will be automatically displayed in the layout. These settings can be saved, exported, and imported into other instances of the application, making them easy to share even with colleagues. If there are commonly used parameters, you can also let us know so we can include them in the application default configuration. As you can see, dummy internal flag W is still the flag column since it has been defined in the application settings yet, while the exported column is currently named dummy external. The GUI is composed of several intuitive sections. At the top of the interface, each tab displays plots for a specific parameter. On the left, we find the tools used to interact with the plots in the current tab. In the main and largest area of the interface, we find the plots we are working with. At the top right, on the sidebar, we find the flagging controls. We can show or hide specific flag values, assign flags to selected samples, and change the flag being plotted. Flags are represented in the plots by colors matching those on the icons. Below the flag controls, we can see the profile controls. They allow showing or hiding profile lines on the plots. By default, the profile of the currently selected samples is shown in red. Additional profiles can be displayed in blue, as we will see later. Further down, we find data related to the selected sample, along with controls to browse when more than one sample is selected. Finally, at the bottom of the sidebar, we find the bathymetric map with all the stations from the file plotted on it. The left plot shows the online map, displayed when internet is available, using ArcGIS World ocean-based layer, offering full resolution zoom. The right plot shows the offline version, used when offline, for example during cruises, based on a topo one, with limited zoom to save local storage. Differences in appearance are due to the different map providers. Here is a brief explanation of how all the tools work, even though they are quite intuitive. Here you can view all the tools icons. Let's explain them. Pan tool moves the plot content by shifting the data along the axis. Box zoom zooms into a specific rectangular region. The lasso select selects samples by drawing a freeform shape around them. You can select multiple samples. If you do, you will be able to browse through them using the controls on the sidebar. For each sample, a table displaying all its values will be shown. Reset restores plot range, zoom, and selections to the default values. Wheel zoom zooms in or out using the mouse wheel, affecting part or all the plot. The other plots displaying the same parameter on the same axis will also be updated. Box select selects the samples within a rectangular area. Tab allows selection of a single sample with one click. Deselect clears the current selection without changing the zoom level or position. Crosshair displays horizontal and vertical guidelines that follow the mouse cursor for precise data inspection. Let's see the flagging process. The quality control task consists on assigning quality flags to the data, where we consider the values are good, questionable, or bad, following the WCE standards. First, a sample is selected to be flagged. Its visual representation is compared across all plots by browsing through the different plot tabs in order to determine whether a different flag value should be assigned. In this example, flag 4 is chosen to update the sample. The flag button is pressed to apply the change, and the update can be confirmed by checking that the flag now appears as 4 in the samples data table. Let's dive into profiles. A sample is selected for deeper analysis by displaying nearby profiles or the profile to which the current sample belongs. There are some controls to perform the quality control by updating the flag values on the selected samples. The flag itself is the button to perform the quality control. The visibility of samples with any flag can be changed with the IS icons. Changing the visibility of some flags is convenient for readability. When the fixed profile switch is enabled, the corresponding profile remains visible even if the flag samples are hidden. The user will keep seeing the profiles even if the samples are invisible due to changed visibility for some flags in the upper section, as can be seen in the following example, where the profile remains in the right panel even when no samples are shown by flags. Pressing the Show Nearby Station button displays a neighboring station in blue. The profile shown can also be selected from the drop-down menu. If more than one sample point is selected, the data of one of them, selected randomly, is reflected in the data table. The user can iterate over all the selected items through the arrow buttons. The flag values for a simple sample can also be updated directly in the data table by double-clicking over the flag value. In the next example, CTD SAL flag have been double-clicked and its value has been changed. At the bottom of the sidebar, a bathymetric map is located. In the map, the stations can be hovered to show their details or selected. If a station is selected, then all the samples that belong to that station are selected as well. At the top of the bar, there is a drop-down menu where the user can choose the parameter on which to perform the quality control, initially linked to the selected tab. Once the flag parameter is changed, all the colors of the plot samples on the current tab are updated with the flag's color for that parameter. In any tab, the flag being visualized can be changed if needed. Data menu. In the Data menu, the Show Data option allows access to all the information currently being used, including both the parameters from the open file and those calculated during the session. The displayed data can be copied directly and pasted elsewhere as needed. Another available option is Edit Metadata. When the file is exported with metadata, a new line is automatically added to indicate that the file was modified by this application along with the export date. Action History. The Action History option is the view menu that provides a list of actions performed on the open file. Some background operations are automatically carried out when the file is opened, and these are also recorded in the history. Also, if a sample is selected and its flag value is updated, this action will appear as a new entry in the list. Calculated parameters. If this menu option is selected, then this form will pop up. Two lists of calculated parameters appear in the screen. The lists on the left are the parameters that can be used in the current layout. The lists on the right are the parameters that can be added to make them available in the current project. If you need to create a parameter that is not in this list, then press Manage Calculate Parameters. This other form will show up. New parameters can be created here. There are some rules to know if we want to create a calculate parameter from scratch. The main keys are explained under the Help button menu. It gives you some hints about how to add columns, functions, and parameters to the equations. Some additional functions from Python, Building Math module, and the Seawater library can also be integrated into the application. The parameters in red mean that they use some dependencies that are not currently satisfied by the project data. If they are green, then they were currently computed and can be added to the current project layout. On top of that, they will be available in other projects as well, because they are set as default parameters. This can be avoided by selecting the parameter and pressing on the Set Non-Default button. To create a new parameter, enter its name, set the precision of unit if needed, and add it to the layout via the project menu settings. Export data. Once a data file is open, the user is encouraged to save the project in the AQC format of this application to track the quality control process. The project can also be exported in CSV format without metadata or in Excel and ODS formats, where the metadata is stored in a separate sheet. Alternatively, it can be exported in CSV WHP format, where the metadata is included as plain text at the beginning of the file. The action history can also be exported. It will be useful to track the change, like the date, the type of action, the flag parameter updated, and the required files to locate that parameter. It will also come with a human-readable description. The software was developed entirely with open-source technologies, and the code was initially published in a public repository as part of the Atlantos project. The repository was later moved here for the phase funded by the EuroGO-SHIP project. This new repository contains the most up-to-date code and releases, and also serves as the platform for reporting bugs, requesting new features, or discussing any functionality. For issues related for stability, bugs, or feature requests, users can be submitted directly to the GitHub page, where response will be provided. The development of this software was funded by Atlantos and EuroGO-SHIP Horizon Europe EU project for enhancing ocean observations. These are the core developers, the development coordinator, and the contributors involved in the application's development.